To the presentation of DBL Process Mining Group 7. First, we're going to start with some background information on the data. The goal of the project is to predict the upcoming activity and corresponding time for a request in the administration system. For this project, multiple predictors were developed. We chose as main dataset BPI Challenge 2017, which has as main attributes case concept name, event concept name, and event timestamp. We've also had to split the data. We split it into training, validation, and test datasets. Sadly, about 13% of the data got lost since we made sure that no case had been split over multiple datasets. The tool can run other datasets, but the prediction model was made for BPI 2017, so the accuracy and the mean absolute error of the time can suffer. This is a visualization of the data after the splitting. You can see it falls between the boundaries. This is a plot of the distribution of the data between all the datasets. Now we're going to the predictors. There are two naive predictors. They are both based on the frequency of occurrences after a certain position or event. We have one naive predictor based on position and one based on event. We took those as baselines. These are heat maps of the accuracy of the event prediction of both predictors. We also have an ROC curve for the naive predictor. Each line represents an event. If the line is closer to the upper left corner, it's more accurately predicted. Regression is a form of linear regression that uses L2 regulations to reduce coefficients of less significant variables. Cross-validation is used to tune the alpha parameter. Processing steps include natural log transformation to shift the data distribution from log normal to normal. After an isolation forest was fitted for automatic outlier detection with contamination set to 10%. 6 independent variables were used for the model. This includes 4 last to last event, season, and the lone goal. On the right you can see a kernel density estimation, which is a way to estimate the probability density function of a random variable. This is made for the lone goal. A temporal convolution network is a modern technique based on dilated one-dimensional convolutions to a model time dependency. Temporal convolution network, a TCN, is used to predict the next event as well as the next timestamp based on the maximum loopback of 15. The model is trained for event and time predictions simultaneously. A deep TCN, more than 400,000 trainable parameters, is used consisting of independent input and output for time and event data, as well as a combined sequence of layers in between. We also have a temporal convolution network based on text. In this approach, event sequences are interpreted as textual data such that additional interdependencies between the events can be exploited by the network. The data is passed through a TCN making use of variable loopbacks such that the previous events in the trace can be used for prediction. For this task, a TCN is a logical choice as the network can be modeled with a large receptive field size such that a long-range dependencies can be captured. The model is built on a TensorFlow platform, therefore training time can be accelerated by GPUs. On this slide you can see the accuracy and the mean absolute error of both TCN predictors, and you can also see the convolution matrices. On the right you can now also see an ROC curve based on the TCN text. Random forest is a machine learning method for tasks such as classification and regression. It constructs many decision trees when training, which enhances the prediction ability. It can solve classification and regression problems and it runs fast. However, it requires numerous computational power and resources. The algorithm of random forest is mainly divided into 4 steps. First, the random sampling are obtained for the decision trees. For each sample, attributes are randomly selected as split attributes at the root node of the decision tree. Repeat step 1 and 2 until all the nodes of the decision tree can no longer be split. Repeat steps 1 to 3 to build many trees, thus forming a random forest. Going to the results. These are the results you previously already saw in the slides. The runtime. The training runtime is colored blue and the test runtime is colored white. The TCN training runtime was calculated by hand. The results are averaged over 10 runs and statistic plot every 100 milliseconds. Conclusion. For the final results. The accuracy for the event is the highest by the random forest and the mean absolute error for the time is the highest at the TCN. We don't think any predictor will greatly improve the accuracy for either time or event since the dataset is quite skewed and therefore it's difficult to train predictors on this dataset.